Welcome! Today, we are going deep inside a simple loaf of bread to uncover the incredible science that happens on its journey from just a few basic ingredients into the food we all know and love. So, let's get right into it. Have you ever really thought about it? How does a pile of flour and a splash of water become this perfect, airy, delicious loaf? Well, it's not magic, but it's pretty close. It's this amazing chain of chemical and physical reactions. So what's really going on in there? What's giving bread its structure, that incredible texture, and that amazing flavor? Let's find out. Okay, so our whole story kicks off with the first and maybe most important step, building the dough's foundation. And this is so much more than just dumping ingredients in a bowl. We're actually creating a complex, living structure right from the get-go. The moment you add water to flour, these proteins that are naturally inside the flour just start soaking it all up. They love water. And that is the very beginning of creating gluten. But at the same time, you're also trapping thousands of tiny air bubbles. And those little bubbles, they are the seeds that will eventually grow into the bread's final, beautiful, airy crumb. And this is where the real transformation happens. Kneading, all that stretching and folding and pushing, it takes that initial sticky mess and it starts organizing the gluten proteins into this strong, super elastic web. Honestly, think of it like creating a microscopic net. It has to be strong enough and flexible enough to hold on to all the gas that the yeast is about to produce. That's what gives you that perfect, chewy bite.
You know, kneading is all about finding that sweet spot. It's a really delicate balance. When you get it just right, the dough feels elastic, it's smooth, it's beautiful. But if you go too far, you actually start to shred that amazing gluten network you just built. The dough gets all sticky again, and it just can't hold its shape. You've got to know when to stop.
All right, so we've built the structure. Now it's time for the quiet part. But it's also the most powerful part. This is the fermentation stage, and this is where the dough really, truly comes alive.
Okay, so let's talk about our microscopic helpers, the yeast. These guys are tiny biological factories. They are just feasting away on all the sugars in the dough. You know, glucose, fructose, all that good stuff. And as they eat, they burp out little bubbles of carbon dioxide gas. That is what makes bread rise. But that's not all. They also produce other compounds that are absolutely critical for developing that deep, complex, characteristic flavor of a great loaf of bread.
And really, so much of this comes down to temperature. Yeast can be pretty picky. At this perfect temperature, 27 degrees Celsius, or about 80 Fahrenheit, it works super efficiently. It creates a beautiful rise and a fantastic flavor. But if you let it get too hot, that fermentation just goes wild, and you can end up with some really funky, sour flavors and a totally compromised texture. Now, this next part might seem a little brutal, but punching down the dough is a really vital step. It does two main things. One, it moves the yeast around so they can find new sugars to eat, and two, it breaks up any giant irregular gas pockets. This is how you get that fine, even crumb in the final loaf instead of, huge gaping holes. It's all about consistency. And now for the grand finale. This is the climax of our whole story. All that careful work, the mixing, the kneading, the waiting, it all leads to this moment. The intense, the rapid, the super dramatic transformation that happens inside a hot oven. The second that dough hits the heat, bam, you get what bakers call oven spring. All that trapped carbon dioxide and water vapor inside the dough just expands like crazy, causing this last huge growth spurt. This is where the loaf gets most of its final size, and it all happens in just the first 6 to 8 minutes. It's incredible to watch. So as that internal temperature starts to climb, a whole series of critical things happens, one right after the other. At 55 degrees Celsius, the yeast just can't take the heat anymore and they die off. Then at 60, the starches start to swell and firm up. That's called gelatinization. And by the time the very center of that loaf hits about 95 degrees, the whole structure, the proteins, the starches, it's all locked into place. The airy crumb is now set and stable. But wait, the show is not over yet. While the inside is setting up perfectly, something absolutely spectacular is happening on the outside. We're in the grand finale of the grand finale now, the creation of that delicious golden brown crust. So how does this happen? First, the intense oven heat just blasts the moisture away from the surface of the dough. As soon as that surface is dry, its temperature can soar way past the boiling point of water, and that's what triggers two of the most amazing reactions in all of cooking, the Maillard reaction and caramelization. These reactions create hundreds of new flavor compounds and that beautiful, deep brown color we all crave in a perfect crust. Now, while the core science here is always the same, bakers have come up with a whole bunch of different methods over the years. You can think of them as different directors working from the same script. Each one creates a unique final product with its own special character. And here are just a few examples. You've got the straight dough method, which is, well, pretty straightforward. Everything gets mixed at once. Then there's the sponge and dough method. This is a two-stage process that's all about taking more time to build up way deeper, more complex flavors. And then, on the complete other end of the spectrum, you have mechanical development, which uses crazy high-speed mixing to get the job done almost instantly. That's how a lot of commercial sandwich breads get that super consistent, super soft texture. So the next time you pick up a piece of bread, you're not just going to see food, you're going to see a whole story of physics and chemistry. You'll see that carefully built gluten network, that living fermentation process, and that final fiery transformation in the oven. You'll see science that you can actually taste.